So our goal is to measure the volume of Lake Lanier.
And we'll use the volume that we find of Lake Lanier to see how long we'd be able to live if the water supply we got only came from Lake Lanier. We chose two areas to obtain data from, and this area happens to be much shallower than the other. Here we measured the distance from a dock to the approximate center of this area and marked it with a life jacket attached to an anchor as a buoy. We will then use that distance to measure that same length on the other side of the life jacket towards the other coast. We then would measure 20 depths all equal distance apart and use those depths to create an equation that defines the contour of this section of the lake. Here we are measuring the distance from the dock to the center of this area. After we found that distance, we used that to measure the same distance on the other side of the life jacket. The distance from the dock to the center of the lake is 203 feet.
We attached a measuring tape to the dock and the boat and drove the boat in a line 203 feet to the life jacket and 203 feet after it. On the left are some of the depths we recorded every time the boat went 20 feet. The measuring tape is shown on the right.
This life jacket is anchored in the center of the cove 203 feet away from the dock. This is a graph of the depths that we recorded in the shallow area, where the life jacket is at the origin.
The second deeper area of the lake we used, like the shallow one, we placed a life jacket near the center of this area. We will then measure 203 feet on either side of the life jacket and measure 20 depths, each 20 feet apart like in the shallow area. Using the same method as before, we attached a measuring tape to the life jacket and drove 203 feet in two opposite directions of the life jacket. We then recorded depths every 20 feet. This is a graph of the depths we recorded in the deep area.
After we found the depths at each area, we inputted the data into a graphing calculator. The position column represents how far the boat was from the life jacket, and that was put into the L1 slot. The depths from the shallow area were put into the L2 slot. The depths from the deep area were put into the L3 slot. And this is a scatter plot that represents both these depths in the same plane. Since we assumed that the lake's contour was similar to a quadratic function, we found estimated quadratic equations that represent the contour of the lake for both areas using our data. To find the equation of the shallow area, we used the quadratic regression function on the calculator, using the position from the life jacket as the x values and the depths of the shallow area as the y values. We used the same method to calculate an equation for the contour of the deep area, using the depths from the deep area. These are the quadratic equations that we created using our data. And this is a graph of both the data that we collected and these quadratic equations in the same plane.
So using the equation found through quadratic regression, we plug it into the integral negative 203 to x f of x dx, which will give us g of x, which is our integral equation, which we can use to find the volume. In the second integral, which is integral negative 203 to positive 203 g of x dx, which gives us 2,218,877.7 feet cubed. So using the same process as in the first lake spot, we then find the volume of the second area, which is 8,976,734.47 feet cubed.
We averaged the two volumes together so that we would get an estimate of the volume at any point in the lake where the surface area is 406 squared feet squared.
Using the surface area we measured and the given surface area of the lake, we made a proportion of surface area equaling volume. After using this proportion, the calculated volume of the lake is 54,845,160.21 feet cubed, which is very close to the actual volume of the lake, which is 45,710,000,000 feet cubed.
To see how long we could live off Lake Lanier, we first had to assume the water was never replenished, and the only source of water in Gwinnett County and Hall County was Lake Lanier. So we found the rate at which water was taken out of the lake by finding the average water usage per day by one person. To find the rate of water consumption for both counties, we multiplied the rate of water usage by the population of each county. We then added both rates together to get the overall rate of water usage of the areas most heavily reliant on Lake Lanier. Based on this information, we were able to conclude that the average water consumption per day of Lake Lanier is 13,996,951.03 feet cubed per day.
We found that a normal person can survive 7 days without water, so we added 7 to the final calculation, which told us that the populations of Hall County and Gwinnett can survive 3,925 days with water coming only from Lake Lanier.